Let us take a look at the characteristics of the database. What separates a database and a file? In a database approach, a single repository of the data is maintained and is defined once the accessed by various users. The major difference between database and file. Basically, the database is the things that we're going to learn in this class, in this semester. What a file can be considered as like an Excel sheet that you created, you try to put something over there, and it is not connected with any other Excel sheets or programs. So what makes the database a database? First of all, it needs to have a self-describing of a database, which is the metadata that we discussed earlier. You also need to separate the programs and the data. It supports multiple views of the data. Different people will have different view of the database. Finally, sharing of the data and multiple user transaction processing. So let's be able to do the concurrency control. And therefore, let's take a look of each one of these characteristics in detail. Self-describing nature of the database system. Database system contains not only the data itself, like Excel sheet. If you create Excel sheet, you put the informations in the sheet, and basically only you would understand the structure of the database. Of course, you can put some headers information over there. However, that's for a smaller scale of the database that we are looking at. For the database system, contains not only the data, but also a complete definition of the database structures and constraints. What they're trying to say is that you need to define for every single column of the table that you are looking at, you define what's the data type, what's the size of that, what kind of primary key, that's the constraints that we are looking at, as well as how does it link with other tables, are all defined in the definition of the database. This information stored in the category is what we call the metadata, and that is the data about the data. It describes the structure of the primary database. So database has the metadata while file don't. A simplified metadata. For example, the university examples that we see earlier, there are 5 different tables. First of all, you need to understand how many columns describing in each table. And then for each table, for student table, it contains of 5 columns, what's their data type and what's the size of each one of that. So this is a simple example of the metadata. Besides that, you also need to define that student number as the primary key, and how does this link with all other tables are also part of the metadata. Installation between programs and data. In file processing, if any changes to the structure of the file itself, for example, in Excel format, you swap first column with the third column, saying that you are writing a program. By changing the structure of the Excel, your program needs to make the corresponding changes. So the structure of the Excel sheet of a file that you are using has a connection with the programs that you are using. In database, we don't have that connection. In database system, the structure of the data file is stored in the DBMS category separately from the access program. Because when programs try to access each columns of the table, it's not saying I want to access the first column or the second column. Instead, it says that I want to access student.name column. So it's not using the order, but using the column definitions to access the information. This is what we call a program data independence. It supports multiple view. For a file, you double click it, you open it, you see everything. In database, you don't do that. In database, you basically need to log into the account, and the account that you are logged in has certain view of the database. For example, my UCA. The view you can see as a student is totally different from me as a faculty can see, because I can see more grades. I can look into my advisee's information, and you of course can only look into yours. The view of my department chair or my college dean will see differently than my view. So the database will support this kind of functionality. So finally, concurrency control is another key thing about the database. That, of course, the file cannot do this. Concurrency control within the database guarantees that each transaction is correctly executed or avoided. So this is an important thing that what we call online transaction processing, or OLTP. That's the main characteristic of the database, which offers the concurrency control. And that, if we don't use the terminology like that, it's basically sharing a data and multiple user transaction processing. So who are the people that are related to the database? There are several different kinds of people, starting with the database administrator, so admin of the database. That is the person responsible for authorizing access to the database. Say that as a student, for a database admin, that will give you the login account. So you will be able to create your own account information as well as the password. Once you are logging in, you will be able to view as a student. So that is the role of the database administrators trying to do. And you also coordinate or monitoring the use of the database, acquiring software and hardware resources. Sometimes you see the degree works. It's something extra that you want to do. That's also how does it integrate with the MyUCA. That's also an administrator's job role. For another different kind of people, it's database designers. This is basically what we try to learn in this semester. Responsible to define the content, create the database, create the structure, constraints, and functions or transactions against the database. So basically, we need to create a database from scratch. And that is the goal of what we are going to learn in this semester. There's also some end users, the people who are going to use it in an easy manner. For example, like Bank of America. You can image that how big of the database for the Bank of America going to be. And as a client of the Bank of America, the view I can see is very limited. I can deposit a check, I can look into my balance, I can do very few things in my database of the Bank of America. And that's why it considers me as an end users. Use a very minimum functionalities of the database. Finally, another different type of person, they are not administrators, they are not creating the database, but they use more functionalities than end users simply because they need to analyze the information they have. So that's another type of the persons that will relate it to the database. Like I mentioned, as a computer science major, what the goal of this class is that I want to make sure you guys can be the database designers, design the database, use the database, manipulate, loading the database, etc. to really using the database. So finally, let's take a look at the advantages of using the DBMS approach. Controlling redundancy. This is the #1 importance of using a database. Control redundancy is one of the most important features of the DBMS. The traditional files approach, each group independently keeps their own file. While computers are not so popular, still taking university as an example, the informations that accounting office holds will be very different from the registrar office. They will still have your names, they will have your ID, maybe they have your telephone number as well as the physical addresses. However, the information they're going to keep track are going to be different. So, the common things between the two offices are what we consider as the redundancy. Saying that you moved, you change your address, and your registrar office make the updates while your financing information office has not updated. That will create an inconsistent problem. So not only the space are wasted, the information can be inconsistent between the two locations, and that is exactly what database try to avoid. So for example, accounting office keep the data on the registration and billing information, whereas the registration office keep track of the registration, student course, and grades. The redundancy in storing the same data multiple times lead to several problems. First of all, logic update. To updating is going to be very difficult because you need to make sure every single location, offices that have your information will update the information. And what if the health clinics also want to update their information? There's a lot of different problems over there. Storage is being wasted, and what we call the inconsistent may happen because they may have stored the same amount, same information, but they are not the same with each office. So this is what we try to avoid. And therefore, using a centralized DBMS to hold a database can avoid the redundancy problem. If you need to update your address, you only need to update one location, while every other office is trying to get your information. They need to come to the database and find that one information that you have updated. It can also restrict the unauthorized access to data. Privacy is going to be a very important thing. And of course, for health clinic offices, this is also a very, probably the #1 priorities they have in mind. Database can also provide storage structures so that the query information can be easily generated. Thinking about if you want to retrieve a transcript, finding out what's your GPA. Right now, how easy it is. Log into my UCA, go into the account, and you can find your GPA immediately. So that's also providing efficient query processing. Backup is also another important thing. Computers can be broken for no reasons. Backup is also a very, very important thing to handle. So the database can provide frequent backups systems so that all the data will not lose if some major crisis happens. It can provide multiple interface to different class of users. Some people need very easy GUI information. Some people probably prefer, for the professionals, they probably prefer the command line operations. So the database will be able to provide this kind of functionalities. It also representing a complex relationship among the data, etc. So there's a lot of advantages using the database to handle the data informations. Of course, all of those functionalities will have the overhead. So when does it not require or not recommended to use a database? The overhead cost of the database will have a high initial investment of the hardware, the cost of defining and processing the data, not to mention you need to hire someone to create a database. The overhead for security, concurrency, control, recovery, and etc. There's actually a lot of different things need to be use the resources to maintain a database, and it's not affordable for all kinds of situations. Hence, it may be more desired to use simply the file under the following situation. First of all, simple, well-defined database applications that are not expected to change. So something that's fixed over there and it's pretty well defined. One table only. They don't need to interact with all other tables, and the information is fixed over there. Sometimes the problem requires database. Ideally, if they can have a database to handle those things, it's going to be good. However, sometimes they just cannot afford the cost. For example, a real-time requirements for some programs that may not meet due to the DBMS overheads. Finally, no multiple user access of data. If you are only defined for yourself, sometimes the file, as long as you know the structure, one or two files that connect with each other, you may write your own program to connect the two, and they are not expected to change much. And that is another example that's not need to use the DBMS. Of course, most of the real life jobs or real life examples requires the database. And in this semester, we try to learn how to do all these things that we have mentioned in the DBMS, which is going to be Oracle that we're going to study. That's going to be your very first chapter.